So for this week, we'll talk about lists here in just a second. Under old videos, you will see some old videos. These ones down here at the bottom. As a matter of fact, I'm going to shift these around a little bit. The newest version. And I'll do some editing there so you guys get some different dates on them. But there is some old videos in here in lists. So this is one where students had some troubles in the past. Understanding lists, so there's plenty of videos to go back and watch if you guys have any issues and understanding what's going on. One of the favorite things this week, no homework, no quiz. All right, so no homework, no quiz this week. Just play with these lists. We'll talk about them today and Wednesday, but no homework assignments this week. So that'll give me a chance to get caught back up on your guys' stuff. All right. So what are lists? Lists, we're going to talk about two different types of, or two different data types. We have list and we have its cousin, the tuple. All right. A list or a tuple is going to contain multiple values, and that makes writing programs that have large amounts of data a little easier to work through. So a list data type is a data type value that contains multiple values in an ordered sequence. All right. The ordered part is going to be the key word there. So the term list value refers to the list itself, and values that are inside the list are referred to as items. All right. So if we have a list, for example, that looks something like this here, where we have a square bracket, we then have a series of strings. So we have cat, comma, bat, comma, rat, comma, elephant, and then a square bracket. So anytime we do a list, it has to have square brackets. You can have any values inside of there you want. It could be another list. It could be strings. It could be integers. It could be floating data types. It could be Booleans, trues, false, etc. Any data type can go inside of the list itself. All right. The key is each one of those items is comma separated. So we can see the comma inside of here. And then you can put whatever you want. So for example, here's a string. This is going to be a what? What data type is that? 3.1415. Float, right? Because anything, we have decimal points attached to it. So it'll end up being a float. What is the true? Boolean. And then you obviously have none as a none type data value, and then an integer down here. All right, so any of those can be stored inside of a list. If you guys are coming from other programming languages, this would be similar to an array, right? So if you're a comp sci major, done other programming languages, this would be like an array. All right, when we get values out of a list, we deal with their index, right? So if we had this list here, for example, and we wanted to get cat out, we would have to put in spam square bracket 0 square bracket. That's because this list is spam, right? So spam equals this list, looks like this right here, right? We would put the name of the list, which is spam. We put a square bracket and then the index of what we want to retrieve. The index always starts at 0, right? This is going to be what trips a lot of people up in lists. The index always starts at 0 and then goes 1, 2, 3, etc. till you get to the end of them. All right. There's 4 items in the list, but the first index is 0 and the last index is 3. All right. So if I wanted to get cat out, I would have spam 0. If I wanted to get rat out, I would have spam 2. If I had just the list itself and I wanted to get the third index back, what is the number 3 index? Be the elephant, right? So 0, 1, 2, and 3. All right. What this allows you to do is build out string concatenation of things that you want to pull out of there. So you could say the, and then spam 1, which is bat, 8 the, spam 0 equals cat. All right. It also lets you retrieve and store values inside of there. If you ask for an index that doesn't exist, you're going to get an index error, and it's going to say list index out of range. So if I asked for the 10,000, or in this case, the 10,000 index, note that I messed that up and I need to make sure I'm clear on that. This is not the 10,000 with the TH at the end index, right? What would the 10,000th index be? Exactly. 9,999, right? Because it's always one less because we started 0. Okay. So if I say what's the third index, it's the third index, not the number 3 index, for example. Okay. All right. Indexes themselves can only be integers and not floats. For example, we can't use 1.0. We will get an error that says type error. Indexes must be integers or slices, not a float. Okay. You can also have lists inside of lists. So for example, we have spam equals the outer list, which has 2 values inside of it. And the first value is a list of cat and bat. The second one is a list that has 10, 20, 30, 40, 50 in it. If I want to reference something that is a list within a list, you just chain the index down to the end. So spam 0 says I want this list here, and I want the 1 index of that, which is going to be bat. And so bat is what gets returned. If I want to get 50 back, I would have 1, which is the second index or the second list in here. And then from there, I go to the 4 index, 1 or 0, 1, 2, 3, 4, and I get 50 back. Anybody have any questions on indexes and lists so far? Okay. You can use negative indexes. Negative indexes allow you to go from right to left as opposed to left to right. So if I want the last thing in a list, say I'm storing a bunch of names or I'm adding a bunch of names in this class like a student roster, right? I want to get the last name on the list, I would use -1. And -1 would return me back whatever the last one is in this list without knowing how many are actually in that list. Okay. If I say -3, that's going to go -1, -2, and -3. All right. We can also use what's called slice. A slice allows us to get multiple values back from a given list. So each one of these is just going to give us 1 value back. If we want cat, we have to go in and put spam 0 or spam what? If I want cat, what would it be from the negative index? -4, right? So -4 and 0 are going to be the same thing in this particular case. If I want to get multiple back, say I want to get bat and rat, we use what's called a slice. And a slice is going to allow us to get multiple back where we have spam, the square bracket, and then the integer that we want to start at. So the index there is 1. And we want everything up to 4, but not including 4. All right. This is kind of like the random number, right? Or is it? Does a random number go up to include? Anybody remember how random number works? So when we do ask for a random number between 1 and 10, we put what? Do we? So random number includes it, right? It's round. It's when we use the range is where it goes up to, but does not include. And I know that sounds tricky, but I'm not trying to be tricky. It's just that's what these are, right? So some of these will go up to and include. Other of them are just up to. So up to and include includes your range command that we use in for loops. And when we do slices, goes up to, but does not include the last one that's listed there. Only the random number one includes the last number. So it would be like random number 1, 10 would get us that. All right. So when we go up to, but does not include, so if we wanted to get back, say, bat and rat, we would say 1:3, which gives us back the 1 index, right? All the way up to the 3 index, but not included. So we would say 1:3, which would get us back 1 and 2. All right. If we went the opposite direction where we wanted it from left to right, we would say something like 0 up to the very last one, which would be -1. So we get the first ones out of there. In this case, it's the first 3. If we want to start at 0 on the left-hand side and go up to something, you can either put the 0 in there or you can omit it, but you still have to have the colon in there. Okay. Same way, if you have a 0 at the end, you can ignore that and just put 1 : at the end. And if you're just going from 0 to 0, which means it gives me the whole list, you would just put a colon in the middle. All right. So if we're playing with this, let's go to pull up idle here real quick. All right. So I have a list called spam. And if I want to get back rat, I say what? Bracket 2, right? Everybody sees how we got there. This one's 0, 1, and 2. What's another one that would give me back rat? Spam. -2, right? Either one of those two is going to get me back rat, going from -1 to -2. If I want to use elephant and I want to get that one, but I don't know what place elephant is in here, how would I figure out what the last one is? -1 helps us there, right? We could use -1. Will always get us the last one in the list. What if I want to figure out what the positive one is overall? Or maybe better yet, better question is I want to figure out how many indexes there are in my list. So we could use something like our len function that we used before. We pass in spam. That's going to give us back the total number of positions, right? And this should be equal to what? 4, right? Because it's going to give us back 1, 2, 3, 4. And then anytime we want to use that, we would have to subtract 1, right? So if I wanted to get the last number here, spam 3, I would have to take the len of spam, which would be 4, and always subtract 1 because we start at 0. All right. That allows us to change different indexes too, once we know what index we want to change. So for example, if I want to change bat to dog, I would say spam 1, right? Equals, and then we can just put in whatever we want it to equal. And it would automatically update that. So if I do something like print spam, and we run this little chunk here, you can see that bat got changed to dog. All right. So if you want to change something in a list, you just have to tell it what index you want to deal with. Right. You can also put two lists together, just like we did with strings. So you can do list concatenation. You could also do list replication. So if I have a list of 1, 2, 3, and I want to add that to a list that has A, B, C, you just put a plus sign between the two. It's going to add those two, or in this case, concatenate those two together. All right, putting it comma separated all the way through. If I want to repeat a given list, say I have XYZ and I want that repeated 3 times, I could do a asterisk 3, and that allows me to have that repeated 3 times. You could also define something like spam equals a list of 1, 2, 3, then say spam now equals spam plus, and then I want to add ABC to it. I could do that and get one full list. All right. Anybody got any questions on how to change a value in a list? There's going to be like 10 operations. Does anybody know what CRUD means? From any of your other classes? Maybe not. Okay, CRUD in the sense of programming. All right, so CRUD is usually your normal operations where you want to add, remove, you want to change or modify, or delete entirely. Okay? So if we want to remove something from the list, we use what's called the delete statement. or a del statement, right? So we give it del, and then we give it whichever index we want it to remove. So if we have this one, cat, bat, rat, elephant, and we say del 2, that's going to delete which one out of there? Rat, right? And not only do we delete rat, but now if we run that same command again, what is it going to remove? Elephant, right? Because now elephant is in this number 2 index. So when we delete that, you're going to end up changing the number of indexes for everything else. It all gets moved. Okay. We use a delete statement when we know what index we want to remove. And we know what index number, I should say, that we want to remove. All right. So otherwise, when we're working with lists, there's a couple different things that you may want to do. So for example, we have this student roster here, right? So we have class roster. We're going to have an empty list, and we're going to say while true, print what student we can even build out a small little menu here, so you can say print welcome to the class roster. Let's do true here. And we can print out our little menu system. So we could say, let's do that. We're going to say 1, add student, print 2, remove student, print 3, print students. All right, let's take that out of while true because we don't need that. Actually, that'll work. And we could say choice equals input. Give me a second here while I put this together, and then I'll explain what we're doing. Okay, so there's a couple different ways to do this little menu, right? We have them put in a choice, and we give them the options of 1, 2, 3, 4. We would probably actually set this to 0. That's usually a better choice. And we could say if choice not in, and then we pass it a list of all the valid options. All right. What this allows us to do is check whether or not that choice is in that list of options. If it's not, then we're going to go ahead and fail it out. If I was to try to convert this over to a number, so if I said integer choice and then said if it's 1, if it's 2, if it's 3, well, then what would happen if I type in letters? Does anybody know? Let's try that. If int choice equals 1, print adding student, just for the sake of being. And then we could go ahead and continue. And if I run this and I type in letters, it's going to break, right? Why did it break? Tells you right there in red. Inval literal for int with base 10 ASDF. It also tells you what line. What line is it on? 13, right? So if we go over here to options, show line numbers, it's got a problem with this line. Well, when I typed in letters, we tried to instantly convert that over to an integer. That's going to cause it to crash, right? So what did we learn that I could do that would keep this from crashing? Yep, we could use a try and except statement there, right? So we could try this. And if that doesn't work, we could accept on something particular. In this case, we could accept on a value error. Or we could just accept in general. And we would print something like, that is not a valid number. Right? So let's try that again. There we go. So now we're at least going to get it's not a valid number, and we have to pick an option from one of the ones up above. But what if I pick 6? All right. I pick 6. There's no error there. But it didn't equal to 1, so it doesn't do anything. Well, 6 is not a valid option, right? So we want to write it in such a way that it has to be one of these options. 1, 2, 3, or 0, right? So how could we write this so that we would check right away whether or not it's a valid number? And yes, you could do this, but instead of converting this int choice to a 1, we could just leave choice as a string, right? We're not doing anything with that number 1. Therefore, we don't need it to be an integer. We could just say if choice is 1 as a string. Now we don't have to have this whole try and except clause. But we could also put this as an else for our if loop, and we could go like that, right? But instead of checking for 1 off the bat, what should we check for to make sure it's a valid number? This kind of goes back to what I had earlier, right? So if choice not in, and then we could pass it a valid list of options. So we could say something like 0, 1, 2, and 3, right? Those are our valid options. And if it does end up being one of those, then we could print that's not a valid number. So let's take this around. In which case, if choice not in those, then go ahead and print this. Then we could go ahead and check, right? And this one would be a continue, so that it would start the loop over. Now we could say if choice was 1, then go ahead and add a student. Elif choice equals 2. We could print removing student. Elif choice equals 3. Printing students. And Elif choice equals 0. Print now, how could we end the program right away? Does anybody remember that one? Exit. Do you remember what module that's from? Sys, right? System. So we would say sys.exit. And in order to use that up here at the top, we would need to import sys. Okay. This variable here is just create an empty class roster. Okay, that's what that line does. And then we're going to go ahead and start our program. Okay, so if we do that, we type in continue and we test this. We could test it for letters. That tells us it's not a valid number. If I pick 6, that also tells us that's not a valid number. All right. I have to pick something that's in that list. If I hit 0, says thanks for using my program, the program ends. If I get a 1, I'm adding a student, then it starts the list over. 2, it's removing a student, starts over. 3, I'm printing the list of students, and the main menu option starts over. Okay, so now we actually need to do this kind of stuff, right? So we say adding a student, but we're not really doing anything at this point. We need to add them to that. So the best way to do that, instead of adding the code under this to actually add the student, we want to create a function for adding that student to our list. All right, this kind of ties back in what we talked about last week, which was functions. So if I want to create a function for adding that, what would it look like? I need to give it a name. What's a good name? Don't overthink it. Add student, right? All right. Do we need to pass anything in to add student? In other words, does it need to have any variables? Or parameters in this case is what we call them when we pass them into a function? Not really at this point, right? Not yet anyway. Now, I want to use that class roster up above so that I can add this student to it, right? So how do I use class roster up here? Does anybody remember about local and global variables? Okay, if you don't, that's why we're playing with it and testing it now. So to use this global variable up here, if I want to change or modify it, I have to specify it inside a function. So it'd be something like global class roster. And what that allows me to do is change this global variable. That variable will then be the same between all my functions that I'm using down below. So anywhere in my program, if I use global class roster, I can always access that list and be able to pull it up. And in the form of this project where we're building a class roster, we probably want access to that roster at all times. So we add global class roster at the top. Then we could say something like adding student. Let's go ahead and take that out here. Paste it up here. And before we can add the student, we need to what? Yeah, we need to get a name of the student, right? So let's throw in a while true and print something like enter name of student. We can call this student equals our input. And then what kind of check can we do to see if that is a valid student? We don't really have a great one right now, right? But we could at least check to make sure they didn't type in a number or something to that regard. So if student, and let's try to convert that to a number. And what would we do? We'd have to put that in a try and except statement like we talked about earlier. If int student right? And on an except, in this case, we want the exception, right? We do not want it to convert over to an integer. So if we say this is a converted integer, we would continue. We would say number's not accepted, and maybe something like please try again. On the exception, and AKA it's not a number, then what would we do? We want to add it to the list. Have you guys learned how to do that? No, the answer is no. You haven't learned how to do that yet. So let's learn how to do that. We're going to use what's called an append. All right. So if we take that name, we could do list concatenation, right? In which case we would want to take the existing list and add another list to it with whatever we typed in. So it'd be something like class roster equals class roster plus, and then we're going to need to put whatever they typed in, which was student, inside a list. And what that would do is add that to the string, get it over there. Now we can go ahead and break. And we might even steal this print statement to put that right above where we actually do the print. And when that's all done, we could print returning to menu. Right? Let's throw in some empty print statements so we get a little blank space. So let's test what happens here. I press 1, nothing happens. Well, let's go look at 1. What do I need to do down here on option 1 in order to run this add student code? Yep. So how do we call that function? Yep. Add student. So that is going to call this function, do the function, and then once it's done, it will go ahead and continue. What if in the middle of this, I decide I don't want to add the student? I selected it by mistake. If I do this and run this now, and I say 1, add a student, and what if I put in something like ASD that says it's not a valid number, and then it moves on, right? No, there we go. Adding student, returning to the menu and going down because it's going to accept ASDF if we go through there. If I say 1, add a student, and I say the student name is 44, it says numbers are not accepted. Please try again. Enter the name of a student. All right. What if at this point I don't want to add a student? I picked add student by mistake. I need to be able to go back. Well, we got to build a clause in for that up here so that we can check to make sure that that happens first, right? So we could say enter name of student or press enter to continue. All right. So how would we check that if they pressed enter? What happens when you press enter on an input? What's the value of that input? It's just an empty string, right? So we need to test to make sure that we didn't get an empty string, because if we did get an empty string, we need to just back out of this menu. All right. So how would I check that right away? If student is equal to 2 of those put together, right? That checks for an empty string. At that point, we can just break. That's going to kick us out of this try loop and start us at this returning menu. So if I come back here and run this again, I want to pick an option of 1, and I say press enter. It's going to say returning to the menu. It never adds a student to our list. All right. You want to build those features into your program. You want to give them a way back out in case they picked the wrong option. Okay. Let's go ahead and on this pick option down below here, let's go ahead and print in another space so it looks a little cleaner. Let's run this again. All right. So now I add a student. Now I'm going to put in Jason as my student, and it kicks me back to the menu. All right. It added them, return them back to the menu. Now I got to have the code to remove a student and also print the students. Okay. So let's add those. We need to remove the student. Let's create a function for that. We got to get in our global class roster. And while true, we want to be able to remove that student. Well, what do we need to do before we remove the student, right? What's that? Exactly. Well, not only check if there's a student, but at least maybe print the class roster so they know what students are valid, right? So we could say print current roster, right? And now we want to print every single student name that's in that roster. So we want to loop through that. What kind of loop should I use to do that? Yeah, for loops are perfect for lists. So anytime you're printing out a list, you never want to just say print, and in this case, class roster, right? We don't want to just dump the list to the screen. We actually want to go through it nice and clean. So to do that, we're going to use a for loop. So for student in class roster. And what that does is every time we go through class roster, it's going to grab the student out of there, and we just need to print that student name. So we just print student. Okay. Then we can go ahead and let them pick down here. So let's throw in an empty print. And then say print, please enter the student you wish to remove. Something like that. We actually want to move that inside of our while true loop. Let's go ahead and get our student name. So student equals input. And then how do we check to see if that's about, yeah, sorry. Yeah. Great question. So let's look at class roster. And for now, we're just going to put this in here. It'll get us stuck in a forever while loop. That's okay. So if I print one, let's add a roster. Let's add another one real quick. Sam, and let's add in Jack. And then we go to 2. It's going to say removing. Well, we obviously need to add our function in here, right? So let's go down to 2. Let's take that, put that up here. 2, and we're going to call remove student. All right, so 1. All right, put some students in there. We hit 2. If we just say print the class roster, it's going to look like this. It's going to print it out exactly what the list is. All right, we want to use it where it goes and puts each one on its own line because it looks much, much better. And when you guys get really big lists, it's nice to print those out. So we can go ahead and remove that line, which I put here. All right. And now we have those, and it asks us which student we want to remove. We have a student input there. Now, how are we going to check to see if that's a valid student? And hint, you have similar code down there in the choice for the menu options, right? So what would that look like up here? If student not in. Yep, so just class roster, right? So if that student does not show up in class roster, then we can do something. And you could either do the not version of that, or you could do the other version of it, whichever one you want to do. It doesn't matter which one you do first. It's however you write it. In this case, let's use the not in. And so if they're not in there, we're going to print something like student not in the class roster. Please try again. Right? And at that point, we'll do a continue. That will cause that loop to start over. Else, in other words, if they are in there, we need to remove that student, right? Well, the thing is we know the student name that we want to remove out of there, but we don't know what index that student's in at this point, right? So let's look back here in our code. We're going to have a couple different ways of doing this. This is showing you how to do the for loops. By the way, if you guys remember your for loop using the range command, right? You guys did something like for I in range of, say, 0 to 10, right? Which would be 0 to 11. And then we print I. And you'll remember the first time around, I is equal to 0. Then it's equal to 1. Then it's equal to 2, etc. This range 0, 11 is the equivalent of having a list that has 0, 1, 2, 3, 4, 5, 6, 7, 9, and 10. All right. That range command basically builds this list on the fly. Whoops, with the square bracket. All right. So that's how you guys were already doing that using the range command. Instead, right now, we're actually using a full list on this kind of case, in which case we provided the list here. We could also just provided a list like this if we already have it built out. All right. Outside of that, we have the in and not in, which is what I was playing with. You also have the ability to do a multiple assignment trick. We're going to come back to that. For now, ignore that. We're going to come back. We want to find the value in a list using the index method. All right. There's a lot of different methods with functions that you want to use. In this case, we want to find out, hey, we have a name, but I need to know what index that is so I can remove it. Okay. So if I want to remove it and I need to find the index, I would say something like spam.index and then pass it the student name. That gives me back the index number, in which case I could delete that. So let's go look at our code. And on this else, I would say something like class roster dot index, and then I would pass in that student name. That gets me a number, right? And that number is what I want to delete out of this whole class roster. So I would say something like del class roster square bracket, and I want to delete whatever this number is. Now, this is kind of inside, it may be a little complicated. So if you wanted, you could say something like index equals this, right? That'll get you back the number. And then we could just tell it to use this index or whatever we stored value here in this delete. Either way is fine. This is just a little easier to read. And if index is throwing you off, you could just say index num, and then you would use the index num here so you know what number to remove. Once you remove that student, we obviously want to take this print, put this right above it, in which case we can now break out of our loop and we could return back to the menu like we did up here. So we could steal this code, put this down here and print it. Okay. So now if we run that, let me get rid of my little code here. Before that, let's go back to our remove. When we get this index number, let's go ahead and just print it so we know what it looks like. Index num, and we can print it. So let's run. And so let's do a 1, Jason, 1, Jack, 1, Jenna, 1, Ben, 1, baby. There we go. So let's do 2. And we press the student we want to remove. And if I type in ASDF, that's not a valid student, right? If I type in Jason, I will get removing student. It gave me back index 0, in which case we then printed del that so that we removed it. We could then see if it got removed by going back into roster and notice that Jason's removed. But we also didn't give them an option to press enter and just get out of there, right? So let's do that again. So we'll just steal this piece of code. We're going to put that here. And first of all, we want to check that right off the bat, right? So if student equals an empty string, we go ahead and break out of this loop. Then we can do an elif to see if it's in there. Okay. So that gave us an option to back out of there. Anybody got any questions over this code so far? Very simple program, but there's several different ways to interact with that list. All right, the last piece we need to do is print this students. So let's create a function for printing out the students. Just call it print roster. And this is pretty simple. What do we print here? It's basically this code, right? Get the global roster, print it out, send it out to the user. Well, if I'm going to use this code here, then I no longer need to repeat all this code up above. I can now just use that same function here, print roster, and I just eliminated several lines of code. Everybody see how that works? That's the reason we use functions as opposed to just writing out that code over and over. Anytime we're going to repeating the same amount of code, we should have a function to do that, especially if it's multiple lines of code. Is there any other place so far in our code that what else do we need to add after we print this? We could do something like this again, right? Where we're printing out, returning to the menu. But at that point, how many times have we printed this out? Like 3 times, right? We have it on a print roster. We have it on the removing the student, and we have it on adding the student. But what's the problem if I add it here? Yeah, and the remove student, as soon as I call this, it's going to say it's returning to the menu, but then it's going to just continue down here. So this one, we don't want to put this returning to menu on this option. We actually want to put that maybe down here where we print the students, right? So print roster. And then we could say returning back to main menu. And it would start it back over that way. All right. Again, the reason we did that is if we want to make this the most reusable, we can't add that kind of code in there. Otherwise, we could only use it that one spot. All right, let's test this program real quick, see how we got it. So we have 1. Let's add in some names. Of course, I just added 2 Jasons. If I hit 3, we can see there's 2 Jasons in there, right? Which is fine. We don't have a way of checking that. Or maybe we have students with the same name, so we probably want to allow that for the time being, right? If we wanted to check to make sure it wasn't already in there, then how would we add that option to our add student? We throw in a check about right here, right? Check to make sure they're not pressing enter so that they can get right out of it. We could also say elif student in class roster. Then we could print student is already in the roster. Right? And then we could tell them to continue, and it would just come back to enter in the name of another student. Okay, so real simple elif, and now we have the functionality to see if that student is already in the roster. All right. Let's go back and look at our list. So we have this option to find what index we want, and we would set that index value. If we want to add values to a list, we would use the append or insert method. Well, this is much better than what we did in our code, right? So in our code on this add, we did this whole weird string or list concatenation in order to add them to the end. It's better to use the append method. So if we use class roster dot append, and then we say student, that's going to take whatever we typed in and just add it to the end of the list. Right? If we wanted to move that student to the front of the list, then we would use something like insert. And so that would say class roster dot insert. And then we need to pass it what index we want to put it in. So if we always wanted it in the first one, we would put 0, right? And then the value that we want to insert, student. So instead of always adding them to the end, if we wanted to always add them to the beginning, we could go ahead and put that here and use insert. So those are your 3 indexes you know so far. You have 3 methods that you have so far. Does everybody see the difference between a method and a function? All right, a function we call down here like this, print roster 2 parentheses, okay? A method is off of a given data type. So this is a list data type. If we do dot insert, this dot insert is called a method that we're doing on this particular list. All right, and that'll be important on a quiz that you guys will work on. What's the difference between a function and a method? A method runs off of a data type. A function is just its own little mini program. Okay. Yeah. You could go back and try to sort your list, right? In other words, you want to sort it at the end. Matter of fact, we're going to learn how to do just that. So we have append and insert. Other methods we would have is remove. So where remove, this is where you know the index you want to remove. You don't know the index, right? You know, in other words, you know the value you want to remove, but you don't know what index number it is. Well, that sounds like what we were doing earlier, right? We had to actually go calculate the index so that we could then use a delete statement. Instead, we can just use dot remove. So let's update our code. And instead of doing this whole weird index thing, all we have to do is say class roster dot remove, and we remove the student from it. Okay, much easier. But that only works if we know the value that we want to remove. In this case, we know the name of the student to remove. Great. If we knew what index we wanted to remove, well, then you need to use the delete statement like we did before. So they accomplish the same thing, but it all depends on what value you know. Do you know the index, or do you know the index number that it sits in? All right. There you go. Sorting the values in a list with the sort method. So what this will do is take a list like this, and if we call that list dot sort, it's going to sort them by number. We would also be able to do this with a bunch of strings, in which case it sorts it alphabetically. So we could always sort it alphabetically if we wanted to, or better yet, add an option into our list to do that. So let's say print for sort alphabetically. We go down here to 4, in which case we need to add it. And then to sort it, all we have to do is take our overall list, which is class roster dot sort. That will sort it automatically, alphabetically. Then we go ahead and print it back to the user, which means that we can go ahead and basically call this code here in order to do all that and then sort it back. Okay. Remember, I'm printing 2 empty lines at the end of this. If you remember, this slash new line will do the same thing. It'll print new lines at the end. That saves me 2 lines of code, saves me 2 lines of code here. I just copy this one and do the same thing, which means I can go back up here in my code and do the same thing here. Slash in, saves me a couple lines of code. Doesn't seem like a big deal now. When you get into much bigger programs, it will. So we always want to write these as efficiently as possible. Okay. Let's go ahead and try that. So let's add some students in there. Jason. And remember, if I put 1 and I put Jenna again, it's going to say it's already in the roster now. So we would have something like Jack, Ben. And if I print my students, we could see that we have those in there, but they're not in alphabetical order. We press 4. Say that's not a valid number. Well, why do we have that's not a valid number? Yep, we added this new choice, so we have to make sure that we list that as a valid option now. Which means to test this, I got to start all over. Jason. All right, so 3, we have our list. 4, I sort them alphabetically, and now they're in the right alphabetical order. All right. Anybody got any questions on this little mini program so far? So we have a lot going on in here. We have at least 3 functions we had to write to add, remove, print, right? Then we also had another function to sort. Although, because this is just 1 line, we don't need to write a special fancy thing up here. However, we probably should, because we need to say that we want to sort it, right? So for the sake of doing this, let's do def sort roster, in which case we'll take in our global class roster. And let's steal our code from down here. And we could even print right before we do that what we're doing. And then I go ahead and do what we wanted it to do. So here, sort roster. Okay. The idea is now if I add that up here to a function, even though it's a similar line of code, that allows me to change this function at any point in time. Maybe I want to sort it alphabetically, or maybe I want to sort it in reverse, right? Maybe I want to sort it from Z to A. So to do that, I would want to give them an option to do this. And we could say print if no, press enter. So we would immediately get something in from the user. We could say option equals input. Okay. Now we need to check to make sure that option is not an empty string. If it is an empty string, so if option equals an empty string, then we could go ahead and just start sorting automatically. Just like we're doing here. If option equals yes, or better yet, because there's many options for yes at this point, in yes, yes, yes. Yeah, that's good enough. Right. Then what we would want to do is we can say alphabetical A to Z. Let's go ahead and steal this. Put that here. And now it's Z to A. And then here we just say reverse equals true. And that will set the option to write that in reverse and print them out in the other way. Right. So that's what reverse allows us to do. We can say reverse equals true. This sort will do it in alphabetical order by default, meaning that all the capital A's will go first, then the lowercase a's, capital B's, then lowercase b's, etc. If you want to sort by lower first, you would say key equals str lower. Okay. There's also a new method out there that came out in one of the later versions of Python 3 that's straight up called reverse, and reverse does the same functionality. So let's go ahead and update our code to use reverse instead, in which case we just call reverse, and it will automatically do that from Z to A now. Okay. So if we have this option, the other option we would need here is they typed in something wrong, else print that is not a valid option. Please try again. And in order for them to try again, we would do a continue. Up here, when we do a reverse, we want to break. Here, we would do a break. And obviously, because we're gathering input, we always want that in a while true, right? So while true, take all this out, tab it up, get us out, print the roster at the end. Okay, let's run that. 1. All right, so 3, we have our roster. 4, start alphabetically. Do I want to do it in reverse? No. We get A to Z right off the bat. All right, if I'll resort that 4 and I say yes, now it's going to sort it back the other direction for us. Anybody got any questions so far on the little program? Okay, so we have the reverse method. Then you guys are going to get into a bunch of different options that we'll get into, and that's something that we'll cover on Wednesday. So if we scroll back up here, there's a little section that we kind of skipped over, and I want to go back and make sure we cover that material. So we talked about for loops. We talked about using in and not in. We also have what's called the multiple assignment trick. And what this does is if we have a list called cat here, and we have some attributes to that cat, right? We're going to call it fat, gray, and loud. If we want to assign those variable names so that they make more sense to us, as opposed to cat 0, cat 1, cat 2, we could assign them a name. So something like size equals cat 0, color equals cat 1, disposition equals cat 2. Instead of having to write all of these out, we could simply say size, color, disposition equals cat. And what that does is it takes this list and automatically assigns these variable names so that we can use them in our code. Does anybody have any questions on that? This is important. This one will show up on a quiz. All right. As a matter of fact, it's on the midterm too. So make sure you know how multiple assignment tricks work and how that would pack that out. Okay. You also have the option to use the enumerate function with lists, which is pretty handy. So say we have supplies here, right? And we have pens, staplers, flamethrowers, and binders. That is a unique picnic. All right. So if we use the word enumerate for this, what that will do is say for index, comma, item in our supplies list, it will print it out. So it will say index 0 in supplies is pens, index 1 in supplies is staplers, 2, etc. What this allows us to do is put that number in front. So we are grabbing the index right off the bat and printing it out to the user. Well, that's even better. If we come back here and look at our program, where we remove the user, we're requiring that they type in that particular person's name, right? And it's a lot harder to type in a full name than it would be just to give us a number of the one you want to remove. So if we actually printed that out in a enumerate function, it would say print current roster. And then we could do an enumerate. So for index, comma, name in class roster. Now we could print that out in a fashion that we wanted to. So we could say print, and we would say index plus space, or in this case, we may use like a colon, space plus name. Okay. That will print it out where they get a number on each one of those. Now, when we say enter the name of the student you want to use or press enter to continue, this still works. Now, instead of saying if student is in the roster, well, now we don't know if they're in the roster because they're giving us a number, right? So how do we know if that's a valid number? You need to be able to check it in a very similar fashion, right? So if student in what? Well, first we need to figure out what the max number of indexes are, right? So how would we calculate that? Len function, right? So len, our class roster, that's going to give us the total length. And then if we want to figure out if that number is in the length from the first index to the last index, what command could we use? Because we basically need to feed this thing a list of indexes, right? So how could we get a list of index numbers? We could use our range function, right? Our range function will start at 0, and we want to go up to the length of the class roster. So if there was 4 in our class roster, that would give us a list of 0 to 4. Does that include 4? What's that? No, in this case, right? Because it's range. It goes up to and includes. I know I sound repetitive, but it's that easy every single time. So range is one of those that goes up to, but does not include. So we throw that in there. That will give us, if there was 4 in our roster, we would want to make sure that the number they gave us was 0, 1, 2, 3, right? This would check to make sure it's in that range. But remember that student itself we need to convert over to an integer in order for that to work, in which case we now have to use a try statement in order to make all of that fit the way we would want. Nah, silly break. All right, otherwise we can use an accept, and now we can print that is not. All right, and this one is no longer going to be our deal. So if it is a student in there, then we want to go ahead and remove this part. So let's go ahead and print removing the student, remove this. Now we know the index of the one we want to remove, right? So we're not going to use this. We're going to use del class roster. And we want to pass it the index, which is whatever they typed in, student. All right, let's run that, see what that looks like a little bit. So now if I add one, I could have something like Jason. All right, so let's print our students out. We got our students here. Let's go ahead and remove a student. And we got too many values to unpack. So for index, comma name, and class roster. Well, let's go back and look at our line 30. We forgot to use our enumerate function, right? So enumerate there. What enumerate does is it basically returns back a tuple with the index number and the list or the name of the student. So when we run this little piece right here, it ends up producing a line that looks like this. It would be, actually it's a tuple, so it's going to be in a parenthesis. So if it's a list, it's got square brackets. If it's a tuple, it's using parentheses. So the only difference between the two is you cannot change a tuple. You can't add, modify, change, whatever. We're going to talk about that more on Wednesday, but you just know that you can't change it. So it's going to have one in there with a tuple like 0, Jason, right? Because that was my first one. And then it's going to have another tuple in there that's going to have 1, Jack. And then another tuple in there that's 2, Ben, etc. All right. So you got this overall tuple on the outside, and it is a bunch of inner tuples on the inside. Then it's going to use that multiple assignment trick you guys just learned, right? So if I have these two in my little list or tuple, I want to assign the first one to the word index, the second one to the word name, and then I can print this out in a fashion that makes sense. Print me out the index with a colon space and then the name. All right, so let's run this out. 1 Jason, 1 Jack, 1 Ben, 1 Jack, and a 2. Okay, unsupported. We can't do an int in a string. All right, well, that's because I need to take this index number and convert that over to a string so we can use it in a print statement. Thankfully, we will learn better ways to do prints here later on. So let's do Jason. There you go. And so now instead of typing in the name of these individual people, I can just type in the number that I want to do, which I should probably change this language here. But we would just say something like 1. It's going to remove a student, says it's not a valid number, try again. Well, we got some bad code here, right? So if we remove the student, delete the student, break, that's going to get me out of here. It should be returning that as it's getting me out of that for loop. Let's see here. Int student 1, range 1, stick 1. Yep, that all looks good. Let's go back and look at my code here. Should not get that's not a valid. I converted it to an integer, but I didn't do it over here where I actually have to feed it an integer. Because this was not an integer, I didn't get the red text that says that's not a number like we would expect. It just failed, therefore this try failed, and it printed the exception. All right, so let's try that one more time. And then you guys are good here for today. So 1, Jason, 1, Jack, 1, Jenna, Ben, 2, remove. I say remove Jason. It removed it. We can print it, make sure it got removed. And we can see Jason got removed. All right. Because those are short names, it doesn't mean much. But if we're putting in the full name, well, then they got to type it exactly like it is in there with the right capitalization, the right everything else. Say you had other things in there than a name, that becomes more cumbersome for your end user to do. So it's much better for you to give them number options at the front, right? If I wouldn't have gave number options up here at the beginning and just said add student, remove student, they would have to type that entire thing in order to do that function. It's much faster to pick a number out of there. Instead of me having to build a number like I did down here, I could use the index of whatever's in that list and do this. So a lot of times for a menu over here, instead of me printing something like this, I will sometimes build out a menu option. So menu equals, and then I do a square bracket, and I could have this where it's add student, and then remove student, etc. Then I can do a for loop through this menu. And the benefit is I only have to change it one place in this list, and it will change it everywhere else it uses it in the program. I don't have to come back, edit this, add an extra valid option. Instead, we could just say if it's in the index range, right? And then for each one of these, once it picks that particular option, it automatically executes what's there. So there's a way we could write that where it's a whole lot easier than having all this in there. For now, you guys can just use what you got here. All right. Anybody got any questions on lists? That's a lot to pack through. That's the reason there's a ton of other videos in there. Okay. We're going to talk more about it. We're going to use the random module in order to give us a random one out of there. We could also use random shuffle instead of sorting. We could automatically shuffle that list, get us back an answer. We already talked about augmented and we got methods. All right. We'll stop this here and we'll see you on Wednesday.